Testing, testing. Is this thing on? It is. Okay. Good evening, ladies and germs. Tests for parallelograms. A long time ago, we learned that there are characteristics of parallelograms. If a quadrilateral is a parallelogram, then its opposite sides are congruent, its opposite angles are congruent, its consecutive angles are supplementary. If it has one right angle, it has four right angles.
Don't get technical with me.
Let's get a little technical. So what we're going to be doing is we're going to be taking those conditions and going the other direction with the thought process on them. So now we're going to say that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we're telling you that you have opposite sides of this parallelogram congruent. Those two are congruent. These two are congruent. And because of that, that makes JKLM a parallelogram. All right. So now if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if you see this situation here, there is a pair of opposite angles congruent, and then we have another pair of opposite angles congruent here, then I tell you that. I said, hey, angle J is congruent to angle L, angle K is congruent to angle M. You would be able to turn around and say, hey, JKLM is a parallelogram. Cool, huh?
I got a bad feeling about this.
You don't have to feel bad about this. You just have to recognize that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if we get this type of situation right here, we got this and we got this. Those two are congruent, which means that segment AC has been bisected. But then we come over here and we see this situation right here, that segment BP is congruent to segment DP, and that means that those segments, that segment BD has been bisected. Well, if those two diagonals bisect each other, ABCD is a parallelogram. ABCD A, B, C, D, A, B, C, D. If you ever watched Malcolm in the Middle before, you know what I'm leading up to.
Don't make me destroy you.
Learn your geometry, and I won't. All right, so now we have a situation that looks like this. Here we have two symbols on this quadrilateral. What this is saying is that we have congruence and parallel. Remember, these little markings right here, those little arrowheads, mean that those two sides are parallel. So when we have that situation, that the same pair of opposite sides, they're both parallel, they're both congruent, we have a parallelogram. Now, sometimes guys forget the fact that they have to be the same pair. So if I have one pair parallel and the other pair are congruent, that's not a parallelogram. That can be another special type of quadrilateral that we'll be discussing later on. But for right now, it's got to be the same exact. It's got to be this situation right here. This one right here. We've got to have both together. All right, so let's do some problems here, and let's see if we can't figure it out. First of all, is the quadrilateral a parallelogram? So let's go through what we do know. Let's say we can take a look here and we see that we do know this segment here is congruent to this segment here. Now, these two angles here are some clues. And we can see that those two angles add up to 180 degrees. And since they're both on the same side of what we would call the transversal segment GH, we then know that segment FG is parallel to segment JH. And if you look there, I have just drawn in those arrowheads. And so, is the quadrilateral a parallelogram? Yes, it is. Why? Because the same pair of opposite sides are both parallel and congruent. All right, is this quadrilateral a parallelogram? Let's justify our answer. Well, we've got 12 centimeters here and 12 centimeters here on these two segments, so those two segments are congruent. We have 5 centimeters here, which is going to be congruent to this 5 centimeter segment over here. Well, if opposite sides of a quadrilateral are congruent, the quadrilateral is a parallelogram. So, we have a parallelogram. The answer is yes. Why? Opposite sides are congruent. Always got to answer why. Okay, is this quadrilateral a parallelogram? Justify your answer. Well, I have these two angles congruent. And I have these two sides also congruent. But I don't know anything about these. And I certainly don't know anything about these. So the answer is, I don't know. Some of you are really good at this answer. I don't know. I see that on your quizzes sometimes. IDK is an answer sometimes. This would be an answer time for it. So some of you will be able to use this answer, which you often do put down for quiz answers on a quiz. Yeah, you'll be able to do that. And I don't know is valid here. Other times, not so much. So, in this case, we cannot justify that. We don't know these here. Opposite angles would not be congruent. We don't know. Opposite sides are congruent. Well, just one pair, but not both. We don't know if anything's parallel. So, therefore, I don't know is the appropriate answer here. All right. So, segment FK is 3x minus 1, segment KG is 4y plus 3, segment JK is 6y minus 2, and segment KH is 2x plus 3. Find x and y so the quadrilateral is a parallelogram. Well, in this situation here, it helps to label some things. So we got FK is 3x minus 1, and KG is 4y plus 3. And JK is 6y minus 2. And KH is 2x plus 3. Now the thing they're asking us is to find x and y so that the quadrilateral is a parallelogram. Well, we know that we have to have this scenario here. These have to be congruent, and this segment has to be congruent. So in order to make this all happen, the magic has to happen. To make the magic happen, we got to make those congruent. So FK, right, because if the diagonals bisect each other, we have a parallelogram. So here we go. We're going to say that 3x minus 1 equals 2x plus 3. Subtract 2x from each side, I get x minus 1 equals 3, add 1 to each side, x equals 4. So I would know that FK is 3 times 4, which is 12, minus 1, which is 11. So FK would be equal to 11. And I would know that HK would be 2 times 4, which is 8, plus 3, which is 11. So that one works. Okay, so now let's do JK and GK. So we're going to end up with 6y minus 2 equal to 4y plus 3. Subtract 4y from each side, I end up with 2y minus 2 equals 3. Add 2 to each side, 2y equals 5. And then y would equal 5 halves. So if we plug that in, 6 times 5 halves, well, 6 and 2 would be cancel each other, so you get 3 times 5, so, well, or 30 over 2, which is 15, minus 2, which is 13. So JK is 13. 4 times 5 halves is 10, right? 4 times 5 is 20, divided by 2 is 10. 10 plus 3 is 13. So GK is equal to 13. So we have checked our work. So our final answers are x equals 4 and y. All right, so we got a new situation here. We're going to figure out how to find x and y so that the quadrilateral is a parallelogram. Well, hey, we've got angles. Now, there's two things we can try to do here. We can try to make angles add up to 180, but that's not going to work. So the thing I think we want to do right now is we want to say, hey, we know that if this angle is congruent to this angle, and this angle is congruent to this angle, then we have a parallelogram. So we're going to say that 7x equals 56. That is an ugly 7 before, right? I had to tighten it up a little bit. So divide each side by 7, x equals 8. All right, we got that one done. Now we know that we've got to make these two here equal to each other. So 5y minus 26 equals 4y plus 4. Subtract 4y from each side, excuse me, 4y. Subtract 4y from each side. Y minus 26 equals 4. I'm going to add 26 to each side. I get y is equal to 30. And we can check these, right? So 4 times 30 is 120. 120 plus 4 is 124. 5 times 30 is 150. Minus 26 is 124. But here's what's interesting too. You can also see here that if this is 124 degrees and this is 56, those two angles there add up to 180. So we can do a little check that way. So we have completely, I believe, gotten this correct here. So that's 30 and that's 8. All right, now we have a different scenario. All right, we don't have any angles, but we have side measurements. Well, again, if a quadrilateral has opposite sides that are congruent, then we have a parallelogram. So what we want to do here is we want to make sure that we have made this congruent to this. Ooh, I'm using the marker there. This is congruent to this. So we're going to go ahead and solve. So we're going to set that up. Let's solve for x. So 5x minus 2 equals 3x plus 4. Subtract 3x from each side. I get 2x minus 2 equals 4. Add 2 to each side. 2x equals 6. So, ooh, that's ugly. So x equals 3. And we can always plug it back in. 3 times 3 is 9, plus 4, that's 13. 5 times 3 is 15, minus 2 is 13. We're done with that one. So this one is what we would say is, we want to say that's correct. So let's go back now. Let's do the next one. 4y minus 9 equals 2y plus 5. Subtract 2y from each side. I get 2y minus 9 equals 5. I'm going to add 9 to each side. And so 2y equals 14. That means y would equal 7. Let's check it. 4 times 7 is 28. 28 minus 9 is 19. 2 times 7 is 14. Plus 5, 19. My work has checked out. I can sit there and say, hey, this is correct. So my answers, x and y, x equals 3, y equals 7. Okay, finally, this one's a tougher one. They want you to graph the quadrilateral KLMN with the vertices of K at 2, 3, L at 8, 4, M at 7, -2, and N at 1, -3, and determine whether the quadrilateral is a parallelogram and justify your answers using the slope formula. So what we need to do here is we got to do a little remembering that the change in y, we call delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And it doesn't matter which goes first or which goes second. You just choose. So I'm going to say that k, we're going to do KL. So the slope of KL. Well, that is going to be, we'll do k first. 3 minus 4 over 2 minus 8. Well, 3 minus 4 is 1, or -1, excuse me. 2 minus 8 is -6, so that translates to 1/6. Now we're going to do the slope of an m, and hopefully it's equal. So n to m, so we got -3 minus -2, or -3 plus 2. And that's going to be 1 minus 7. So -3 plus 2 is -1. 1 minus 7 is -6, so equals 1/6. So those two are equal which means Km, nope, let's do this, watch this, watch this, watch this. These two are parallel. So now we want to take a look at Kn and Lm. So let's go from K to N. So 3, so the slope of K to N. I always do the first letter M, so Y first. So 3 minus -3, which becomes 3 plus 3. And 2 minus over 2 minus 1. So that's equal to 6. Now we have to do L, let's do ML. Let's go from M to L. So the slope, oh, there goes my phone with the stock market stuff. M to the slope of ML. So M, -2 minus 4 over 7 minus 8, right? We want to do them in order. M to 8, M to L. That's what I do. That's what this little notation does to remind me. So I've got -6 over -1, which is equal to 6. Hey, boy, howdy, look at that. I've got the same things here. Equal, equal. So we can go back over here and say that these two are parallel. And we showed this. Now, one of the things you can kind of do is if you graph this, okay, you can sit there and go rise over run, right? Well, I went up 6 and over 1, and that's 6. Again, up 6 over 1 here. Over here I went up 1 over 6, up 1 over 6. So if you can count those, go ahead and do that, okay, on a quiz or a test, if you don't want to go through all the formulas and do it that way. Now, if I ask you to do that, and this is the important thing, guys, keep this in mind right here. If I say this, justify your answer using the slope formula, then you're going to have to show this work here, all this stuff, okay? All of this beautiful math work here. That's what we're going to want to, whoops, come on, why aren't we drawing? Okay. Anyway, there we go. We want to show all this math work right here. Okay. Anyway, guys, your assignment will be posted on Google Classroom. Make sure you do the work. See you soon.
You don't know the power of the dark side. Perhaps I can find new ways to motivate them.
That's all, folks.
Do your homework.